Today I'm going to talk to you about repairing the LV6048. The LV6048 is a pretty unique unit. It's got two separate 3 kilowatt inverters inside over there. And the quickest way to kill this inverter is to cut the battery voltage while it's busy inverting. In other words, a lithium battery that's underpowered, for example a 5 kilowatt hour battery, it's limited to 100 amps. Now this is a 6 kilowatt inverter. So 48 volts times 100 amps is the maximum the battery can supply is 4,800 watts. So it's easy to turn a pump on. This inverter is trying to start the pump, maybe peaks up to 6,000 or 7,000 watts. The battery instantly trips. This inverter is it doesn't have the time to shut down properly, so it can kill it. So the biggest killer, like I said, is a undersized battery. Especially a lithium battery, because it's a digital battery that just turns off the moment it overloads. So you can see over here, if we had to connect this onto the battery right now, there's a dead short. In other words, actually not, I'll lie. There's no dead short on this unit. Normally if there was a dead short on this inverter, I'd be putting the power supply on. I'd be putting it across and you would see 5 amps on this power supply is the maximum it can supply. And the voltage will drop to 0. Okay, if you had to use a battery to supply this thing, your battery can put out hundreds of amps and cause damage. Okay, so it's imperative that you have a power supply like this that's limited to 3 amps or 5 amps or whatever the case is. So before we get going, we connect our power supply on to make sure we don't have a short circuit. All right, this one so far we don't have a short circuit, so we can start by turning it on, and let's have a see what fault it is. And the biggest failure is this fault 09 on these units, is improper shutdown, and it does do damage on the main boards. Okay, so it takes a while, and you can see it draws about 1 amp. It's looking pretty good so far, but there's no output. Okay, there it's beeping. Have a look there. So we've got fault 09 on the left hand side and on the right hand side. There's 2 boards in here. Now if there was a dead short, let me just turn this beeping thing off. Okay. Okay. I'm going to turn that off. I cannot handle that beep. Okay. So you'll notice it actually has 2, and we've taken this board out. This is the PAR board. It hardly ever goes faulty, but it's the one that switches your AC output on when it needs to. So hardly ever. It sits on top over there. So we have 2 independent inverters. Here's a charge controller over here. It's connected to the PV1 input, and there's PV2 input connected to its own charge controller, this board over here. Now the fault 09 is a main board failure, and it's a small component in the back. I know which component it is. It's not worth my while to change it out. So it's got 2 inverters next to each other. Okay, this is a control board over here. Have a look in there. That's the control board, and this control board has a little jumper on it over there, and that little jumper tells it it's the master. So it's quite easy to switch these 2 control boards around and just move that jumper over, and whichever has the jumper on, that's the master. So the master is over here. It's also possible sometimes if we've got these 2 inverters and one, let's say we have a dead short on our power supply, so we're not sure if this one is dead short or that one is dead short, then what we need to do is, first thing we do is we pop the covers off over here, and I'm just going to use a little plier or so, or if you're really frustrated, you can put your fingers in underneath there and just push the plastic up. Man, normally it's kind of easy. Okay. Or a screwdriver, just pop them out. Just a little plastic tab like that. We keep them. I'm really battling with these little tabs here. Usually we got them off. Okay, there we go. So you'll notice underneath here, if I lift this up, this plastic. So here we have our positive bus bar and our negative bus bar. This is where the two inverters will join each other. So in order to figure out which inverter is causing the short circuit, sometimes we have to connect this wire, the negative wire or the positive wire, and see if the short still persists. And then I can take my battery wires, my power supply wires, and connect them directly to these cables without being connected to that inverter to see if there's a dead short on this side as well. Okay, so it's just putting the battery straight on here and seeing there's a dead short on the unit doesn't tell you which side it is. You have to isolate by supplying power individually to the left side or the right side, and this is where you would do that. Okay, so we're going to continue by taking this cover off. And just before I get going as well, sometimes one inverter might be dead short, but we're not sure if the other one is fine. Now you'll notice that this display over here is connected to the one that's the master with a jumper on. Now people call me and say that there's glue over everything. The glue is just like a hot glue. You can use a needle nose pliers. Don't use my broken one like that, but just take a needle nose pliers and you're just going to kind of gently squash the glue, and use a different little cutter over here. Just grab it and it'll come off pretty easily. Okay, even just a screwdriver, just pry it off, and it takes a little bit of, but just don't pull on the wire. Whatever you do, don't pull on the wire. We don't want to put undue stress on the wire. Pause. Okay, so the glue, I just took my needle nose pliers, just pull it off like that, and now this little connector will come out. Okay, we also need to get this little grey one off as well, and just careful you don't grab the wire though. You can hit the plug, and this glue is not very tolerant to pressure. So, and my needle nose pliers is not. So I ended up using that sharp side cutter just to kind of scrape the glue off the top corner over there, and there's a bit of a glob, so I cut the glob off over there. And then start moving it, and there you go, it pops right out with that glue. You can just take the glue with your finger, put it off, throw it away. Now, we can also put this LCD display, we don't need to move the buttons over. The buttons can stay there, but we can also move the LCD display over to the other side. If one unit was dead and one unit was alive, and see, and turn it on as well. And hit the power supply button over there. Hit it on and wait till it comes on. It'll take a few seconds. Notice this says SL, so it's for the slave. All right, and in a short while it'll tell us if it also has a fault on it. Okay, so it tells us also there's a fault 09 on both boards. So unfortunately on this one we'll have to change out both boards. Usually, let me just turn this beeper off. If it says F09 on that side and 00 on this side, or no fault, it usually just means this board over here is faulty. The reason it said F09 on both of them is both boards probably need to be changed out. Take one main board out, and you need a screwdriver. Put these nuts back on. Okay, put them back in there. That's the shield to move the air through the heat sinks efficiently. Okay, now he's going to undo this screw here. Screw at the back. Now, so those screws are mainly done. Now, what it is, these two screws in the middle, you see there, if you go closer, it says battery plus, battery minus. Okay, this is where the actual charge goes through to the main board. So if those terminals are loose, you can also have a charging problem. So those two screws are pretty important. All right. Now, we only have 2 ribbon cables. Okay, so now we have 2 ribbon cables that we need to take off. The small one, which goes to the main board over there, and then the bigger one, which goes through to the control board, this control board we showed you earlier. And the control board is basically the whole brain of the system. That stores the programming. So also remove these 2 screws over here. That's out. And there's 2 ribbon cables that went in there. And that's the MPPT board. If ever if the solar won't charge anymore, and you've ascertained if you've gone through everything, it's usually this board over here that's the problem. Okay, MPPT board, will be putting that back soon as well. All right. So taking out the main board, a little bit tricky, more tricky. Okay. So the best thing over here is take a picture of where everything goes. But it's pretty easy to figure out. So just have a look. If you're going to just analyze things, see to COM board over there. It says over there to COM, and you can see, this is the COM board. All right. And this wasn't plugged in either. And that's the COM board over there because it has the communications, the USB, etc. So that's pretty easy. To COM board. All right. The next one, it says to CAN. Okay. The CAN is this long board over here, which is not the COM. So pretty simple, 2-pin plug over there. And you can see it says grid neutral, and you can follow that as well in international terms. Blue is neutral and brown is hot, and I know in the US black is hot and white is neutral. So just a little bit of a remembering. So you can just see grid input neutral, and this wire follows through into grid input neutral. You could just chase it through. Okay, and also they're marked as well, so it really is pretty easy. If I can just pull this wire off, give it a bit of a pull. It says input, so grid is input, so IP neutral. All right, and let's see what this one says. Output live 1, and that one over there says, you zoom in there, it says output live. Okay, so pretty simple to get this done. Grid live. It says input live 1, which is grid, and then output. Okay. Takes a bit of force pulling those off. All right. Now we've already figured out where these 2 go, to COM board and to CAN. All right, those come off. Then you've got the 2 fans over here. And that doesn't matter which way around they go. These we can leave these in. These are just heat sinks that go from the heat sink onto the main board. That can stay. This little board over here, we're going to keep this, put it to the side over there. And now we could either pull out this control board if we don't want to, if we're getting scared where all these wires go to, we can just pull out this control board. It's quite simple. We just loosen that screw over there and get a good set of magnetic tip screwdrivers. Maybe this one could be better, but this was a gift from one of our watches, and much appreciated. Oh, there you go. And I'll just pull this control board out. It's pretty straightforward, just goes straight in there. And there you go, all that wiring over there now, I don't have to worry about that. And put these screws on the side. And the screws I'm going to undo are all marked with the little screw symbol over there. If you want to use a battery drill, go for it, all right? I'm just doing it with a screwdriver just to make the video a bit longer. How's that? I'm probably going to speed this up as well. And if ever you guys, while I'm busy showing you this, if ever you guys wanted to remove the bonding and ground neutral screw, there it is right there. It's actually got a symbol on. It's got a ground screw on there as well. So you can just remove that screw if ever you wanted to, not that you need to. I've never had a reason to remove it, but I know a lot of guys out there that want reasons for things. And wherever it just says a screw symbol, all right? And you can see if it's a cheese head screw as well. The cheese head screw's got some copper around it. This is also a fuse as well. Some guys blow these fuses. That's a good thing to test, is just put a little skinny piece of wire across there if you can't find a fuse. A little skinny piece of wire. Put your power supply back onto the unit. Obviously, if there's a dead short, the fuse is not blown, because if it's open circuit and the fuse is blown, I mean, that's how fuses blow, open circuit. So that fuse is not blown, just a piece of heat shrink over a piece of, and you can normally see that it just blows black out there. So this fuse to me is fine. If you want to check with a meter, you can put it on ohm scale and measure across there, it should beep. And maybe I'll do that later. But these little heat sink wires, they can stay there for the temperature sensors. So not too many screws left over here. This strip of plastic, we'll be changing out the main board. We're going to keep that as well, so don't throw that away. Don't throw that little piece of PC board that was over there, little piece of resin. And now, probably the hardest part. All right, you can put that light on as well. That's pretty good. All right, and then there's another ground screw there. All right, so now that is the easy part. And there's a bit of a big blob of glue and a thermal pad. That was the easy part. Now the most difficult part is, and there's also a little screw under here. And a lot of people miss that. This little screw here. If you could organize as a socket, please, that goes over these nuts here. And that's just got a little black screw like that. Now we've got to take these bolts loose over there. So this whole board is going to lift up. We're also going to have to also loosen these little screws over here. And thank you. I think it's a 10 millimeter. And then you can use a needle nose pliers if you want to, or I think it's a 5.5 millimeter socket that goes on those little screws. All right, thank you. If you could organize for me the little socket head for those tiny screws there to lift that fan off. Okay, keep these guys in a safe place. Just throw them down over there. If it's on the wall, obviously you get a different problem. And so now, a little bit of a pain. You've got to take this loose as well. And then you can change that socket out to a small. And lift this up off over the terminals. So you're kind of freeing that main board to come out now. Okay. And now, okay, so that main board's free even though those bolts are still on there. Okay, it'll slide out, and there's another screw in the bottom there as well. Okay, they made sure that you were fully screwed before you got this job started. Okay, and this is a 5.5 millimeter socket. Okay, stick it on there. And another one over there. Now, if you don't do this, if you don't get these two little fans out, there's no way for those negative terminals. I'm just going to pull that out there, leave the nuts at the bottom. And the fans can get pulled out now, over there. Okay. Now this whole board should lift out, unless I missed a screw somewhere, and it's more than possible. Oh, there's another screw over there in the back. Just grab me a main board, 2 main boards for this.
Good, right here.
Okay, thanks. Okay. Now it should hopefully come up, and it comes up kind of gently. There's a big sticky glob that I'll show you at the bottom. Just give it a little bit of a pry. If it does that, you know all the screws are out, okay? I know some guys go, man, this thing just won't let go, but this is the hardest I've ever had it. Unless there isn't a screw. Yeah, I'll be darned. One more screw in the middle over there. That's why it was pivoting. Okay. I'm not looking directly over the top. All right. So now, with a bit of luck, and if there's another screw, I'm going to go. There you go. All right, so now, and you could also take this loose as well if it's going to help you. All these screws coming loose in the front will help you a lot, but it's not necessary. We're able to just get that out of the way like that. Oh, okay, and while I'm pulling this off, I want to show you some more cables. These are all loose over here. This one goes to the board, this PAR board that sits on top. You can pull this off as well because you're going to need this cable. All right. Now, what separates these two boards, they're exactly the same for the left and the right side. This one over here goes to the power switch in the front, which is this little click switch here. That's the power switch. And then this little jumper over here, this one goes to the MPPT board, and it says SCC on it usually, SCC. All right, so SCC is normally solar charge controller. And then this little cable goes onto the same board at the same spot on the second side. This is the only thing that links these two boards together. All right, and there you go. This board comes out. And we're going to keep this piece of paper as well, okay? So this is the bugger that was sticking us down. It's like a gluey rubber, like a silly putty. And you can see where it goes. There's a slight little silhouette on the outside over there. I'm just going to stick it back where it came from. And we're going to change out this board. Now this had fault 09 on. It's some of these transistors over here for this. Usually this one or that one or that one or that one, if you really wanted to get into the details. And you can even see on the disassembly guide, it will show you what those little component parts are. And that little piece of paper just peels off. It's used to insulate the MPPT board from the heatsink. All right, so there you go. So those are the two standoffs where the battery for the charge controller. So if you've got an 80 amp charge controller, you can have 80 amps going down these pins over here. If those pins are not tight, you're going to have problems, charging problems. So I'm going to mark this as old. Okay, just use a marker and say old or whatever, or fault 09 on there. And then the second board, just lift up all these cables. Make sure we get no screws or nuts lying underneath. See, and that is pretty simple. It's a little bit less than brain surgery, but you don't need to be a doctor. So that's it. Okay, and we just put the screws back in reverse order. And once we've got the screws in, then we'll show you how to connect the wires again and move on to the next. This side is going to be exactly the same as that side. Okay, so no difference, just double the work. And we're going to just put the screws back, and then that's it. Okay. And then you got a cheese head screw, and these are normally used for grounds. Okay, wherever you see a ground symbol, the cheese head screw is that, and that little hex head screw is usually for the perimeters and for the non-grounding. So you're just going to see wherever there's a ground point over there marked, and there's about 3 or 4 of them. And the reason I'm shaking because it's dinner time and I'm hungry. Dang. Okay. And then you can see there's another ground screw over there because it's got the copper around it. Okay. We're just about there. We still have lots of screws left. There's one in the center over there. There's that one. That one's got a little flange on it.
It goes up on this one.
One with the flange, with the washer on it. Okay. I wouldn't get too hung up about what screw goes where. It's not usually that important. It does help at the end of the day. And all right, so then let's go through the connecting back up again. So we know those 2 connectors are for fans. This one over here is for COM board, 2 wire, 2 pin, and you can see there it says to COM. So that's going to go there. This one's going to this long board, which they call CAN. It's going to go in there. Then output live 1, and that's output live is over there, OPL. Input neutral, and that's grid neutral, which is same as input neutral, and input live 1, which is grid live 1, L rather, and grid neutral is the last one left, so it has to go there. And then we can put this control board back in. Now make sure the pins all line up. Don't get this thing crossed over by 1 or 2 pins. Okay, just get the first pin in, lined up with the first pin, push it down nice and gently. Don't force it, because if you bend the pins, you're screwed. Okay. Now we're going to put those screws in over there, hold this control board down. And the other side as well. And all right, that's enough for now, and then we'll quickly fast forward through to the other side. So if you want to, we can actually turn this thing on right now. We don't need any of the solar wires in. We'll need this. This is for the solar charge controller. Let's just get these wires in so that we don't forget where they go. This is the wire that goes to the next unit. That's important. Yeah, goes there. This is the wire that goes to the solar charge controller, SCC, and goes in there. And this is the power wire from the push button in the front, or the switch in the main thing to turn it on. Okay, so we can run it without the solar charge controller connected in, without the solar coming in. There's no solar, there's AC output. We can move the display over to that side. And I want to start it up and see if fault 09 has gone missing from the right hand side. Okay. And if you're using a battery, like I said, I wouldn't use a battery to test this thing because just too many amps. And if you have one little fault, it's going to amplify it and blow your whole system. So I'm just going to push these wires up against here. This is a pain. Alright, so I'm going to turn the power supply on, and also careful you don't make a dead short over here. No, wrong one.
Oh,
This one.
oh, sorry.
Okay. And 48 volts is not going to shock you, okay, guys? I mean, it's a myth that 48 volts is dangerous. It's not. Maybe if you didn't have any skin on and you were helped out the pool, it would shock you. It just goes in there. Let's go to the SEC. Nothing else you need, all right, to start it up. Let's just pull the display out. It's probably going to screech as well,
Because the fan's not there.
the fans are not there. Oh, that's going to be fault 01 on this side. What's the bet? Because there's no fans. Okay. We're more worried. Fault 01 we can deal with. We know that's fans. There we go. This side says it's outputting 120 volts. It's happy. But I'm sure in a few seconds the other side's going to... There you go. This one says fault 00 and then fault 09. Alright, so this side still has a problem. Alright, so we turn the unit off. We turn the power supply off, and which tells us we still have the other side to repair. Okay? Just make sure all of these are tight. It's a new main board. Remember the old main board had different problems. This one over here, just make sure like that, gives it tight. If it's loose over here, you're going to have a problem in a few months, okay? Because you've got 80 amps going down those poles over there. The connection's bad at the bottom. It's just going to get worse and worse and worse. Hot spot, okay? So now we just put the MPPT board back on. MPPT board goes on there, that little spacer over there, okay? You got to do it that it actually fits on. Okay, my brain is not working right now. There it is. There it is. There we go. I got it. There you go. And then that little piece of plate, that little piece of plastic or paper, that strip over there. Okay, that little strip goes in there. Where was it? There. Way around. Man, I'm hungry. It's late, and I'm tired. Hope you're not recording this. Where the hell? Oh, it wasn't like this. There you go. Okay. That little strip goes on there. Those two holes line up.
And Bob's your uncle.
Yeah, and Bob's your granny. Then those two cables go back in. Nice and tight. Now remember, we haven't put the plastic cover on yet, so don't go crazy and screw everything back in and go, oh, and then you forgot about the plastic cover. Then these little screws go back in. Get that plastic cover ready for me. Now, before you go tightening down wires, we can do the back ones over here on this charge controller. Those are still okay. And remember, the most two important screws are these ones over here. Without those two screws in there, your solar is not going to charge, ever. And any wire that's kind of pushing against the metal, just push it out the way, because that's a future problem with voltage and stress, insulation stress. Okay, so we're almost ready to put this thing back in. Those two screws are going to go in first. Over there. I got them here. There's your bolts of screws in the back here. Okay. And just take note, if it was a grid down scenario and you really didn't know how to fix things, those little fuses over there, see it says F1, F2, little white guys, F1, F2. If you were an electronics guy, or you know, who knows in the future, and there's another 2 fuses over there, if you wanted to figure out, you know, why this thing wasn't charging, and you could put your meter across there, solder a piece of skinny wire across or so, and find out why maybe a fuse went wrong before something blew up. Not that I've ever seen those fuses blow, but I'm just pointing them out. Make sure those are tight as well. All right, battery pass, and then the cover goes over. Okay, before you do anything, man, I've done this 100 times where you haven't put the wires through properly. I might do it again today. Pull these wires out. Okay, looks like we're getting it right. And then the screws, those little press studs, you get a chance, one goes in there, get that in as quick as you can, and then the screws are going to go in to those holes there, and put that all neatly down. One more press stud in the side there, plastic over there, and then also make sure, some guys have put these things back together again and then they get a fan fault. It's because the plastic is stuck in the fan. Okay, so you can just make sure that you've done it nicely. Those 2 screws are going to go back in there, press stud over there, press stud, and pretty much ready to go. This is going to go, it doesn't matter which side this goes on. There's a black and a red wire, there it is there. Doesn't really matter which way these 2 go around, but keep it the same way. I mean, you've got another example right there. Keep it real. And okay, that's it. And then the PAR board, I'll tighten these down shortly. The PAR board, that's going to fit in there, goes to the main board, goes upside down. And luckily, I didn't get the order wrong, so I looked at the other side. If I'd put these screws in there now, it would have been too late. So all these holes got to line up with this studs over there, and get a screw in there as quick as we can. Where they're gone now. Oh, there they are. Something fell down there. Doesn't sound too good.
It's the nut off your black wire.
This is the nut off the black wire that fell down. Oops, where did it fall? Which side? Down by me or that side?
No idea.
There it is there. So just before. And yeah, I'm going to get a lot of things saying you should have done this, you could have done that, would have, should have, could have. I'm grateful for those things. Never too old to learn. But sometimes you can be too old to care. So. All right, so then those other 4 screws over there, 1, 2, 3, it's 4 over there. Then there's 2 screws that line up there, 2 screws that go in there. And we're good. That's 1/2 done. 50% done, another 50% to go. Okay, so I turn off the annoying beep on this thing. Still giving fault 88. And this is a pretty rare thing. We do have fault 88 if the battery voltage starts out pretty low. So fault 81. Fault 81 is because I haven't plugged this unit in yet. Fault 81 is this control board over here, not communicating, the left and the right side is not communicating properly. So anything 80 related is communication between the left hand side and right hand side boards. Now, I was I changed out this board over here. I had a board here to see if fault 88 would disappear. and I changed the board out. It did not change. So because there was a blowout on this board that I showed you earlier, we're going to change out the control board to see if the control board is perhaps got hurt along the way as well. And we just took the annoying beep off, setting number 18 over there, beep off, so we wouldn't hear that alarm and the beep. I'm going to stick these cables back in, and we just saw fault 81 now, which means that this control board didn't have any power on it. Now if I power it up again, we should go back to fault 88, which was the original fault that we had. And like I said, sometimes it's voltage related, but I've got this set up at 56 volts right now, 58 volts, still have fault 88. So we're going to pull this guy open, turn the power supply off, turn the switch off, turn the power supply off, open it up, and that screws out the way.
Where's the dish that you were looking
Yep.
for?
Then we're going to change out this control board over there just to give it a try. And if that doesn't work, then we can change this control board and that one. All that changes is that little pin, 2-pin adapter, which I showed you earlier, which one makes this the master and that the slave. Okay, we're just going to go ahead and do that. You can see the glue on there. Just use the needle nose pliers and you can pinch that off. It's pretty cold here today, so the glue is pretty fragile. If it gets warmed up, the glue becomes like putty, and then it kind of likes to stick a little bit longer. But right now it just cracks off. As you can see, it's middle of winter over here. And okay, so just pull that plug off there. The next control board ready. And make sure the pins are off there, so that's the slave. I'm not going to change the tabs just yet. I'm just going to stick the board in to see that the problem goes away. Okay. Looks like they all line up. Cable's there. Bring it back, turn the power supply on, start it up. So we changed out this board already, swapped it out with another one, still fault 88 over here. We still have fault 88 on this guy, so now we're going to change this control board with that control board that we just put in now and see how that works. So if you look over here, this might have been the cause for fault 09 on both sides. So this unit blew out, whether it was overload or under voltage on the battery or whatever. But remember, the unit works the hardest when the battery voltage is the lowest. Okay, so I suspect that was the problem, and this would have put a dip in on the power supply, or the power supply might have had the dip already and caused both main boards to blow out. But here you can see that this is clearly the fault over there, and these are little diodes on the MOSFETs. But none of the MOSFETs over here are blown, or the IGBTs. Haven't looked at what they are, but the rest of it is fine. So we can probably keep this board, and when times get tough, we could use spare parts over here to repair another one. But that's basically in a nutshell. Okay, here's another example of how you can chase the goose, right? You can look at all these other complex problems, but the simple problem was this little cable that I showed you earlier connects from one inverter to the next. It actually just goes down in the main board to the main board. If this cable was off, fault 88, because the two inverters couldn't communicate with each other. And so now we put the old control board back in, and we've got everything as normal as it is original condition. So just remember, fault 88 is this little cable that connects those two units together. It goes into the LV port over there. Okay, so now we turn this guy on, hit the power supply button, turn the unit on, 58 volts, and watch over there. And there you go. It's outputting voltage perfectly. Okay, so that's the end of the repair for this unit. The next part of the video is we're going to concentrate on how to configure this guy. Alright, so we're going to close this up and close the top up, and now we're going to wire power in to the bottom and solar as well. Okay, so turn the switch. When this thing is on inverting, don't switch off the battery, because that's what caused the problem in the first place. Switch it off with the switch first. Click. Then you can turn the battery off the right way around. Okay. Changed out the main boards on both sides. This is going to be the first time we turn on. Now, there's also a little thing, a nuance I've got to tell you with this guy. If the voltage is too low, at 48 volts, you can sometimes start it and it'll give you a fault at 88. So if it does that, I would make sure first just to leave the inverter in the off position. Connect your solar to the input. Let the solar wake the system up, charge the battery till the battery gets above 55 volts or so, and turn the unit on again. I'll attempt to see if we can get that fault, just to show you. If this particular unit doesn't like coming on with the battery voltage too low. So this is after we've changed out both main boards now. There we go. True to tradition, fault 88. Okay, just what I was talking about. So to turn this thing off, fault 88, turn it off. Now, like I said, you're going to have to charge the battery even more, maybe up to 53, 54 volts. Let this unit turn off. I'll just turn it off quickly. It's the beeping. I love that beep so much. Turn it on. And there we go. Fault 88 as well. Pause there.